Okay, this problem says the radius of the Earth is about 6.38. There's the Earth. The radius is about 6.38 times 10 to the power of 3 kilometers, which, by the way, is the same as 6.38 times 10 to the power of 6 meters. Now we have a spacecraft which on the Earth, so if this spacecraft was sitting here on the Earth, its mass, its force of gravity, actually, its weight, which is basically its, whenever they say weight is equal to the force of gravity. Okay, so they give you the weight as being 7.2 times 10 to the power of 3 newtons. Now, that's on the Earth, on the surface of the Earth. Okay, and we all know that force of gravity is equal to mg. So therefore, for this spacecraft, we know that mg is equal to 7.2 times 10 to the power of 3 newtons. Okay. Next, it says the spacecraft moves away from the Earth. What is the weight of this spacecraft at the following distances? So, distances above the Earth's surface. So you got to be careful here, okay? Because what they're giving us is distances from here. So they're saying distances away from the surface of the Earth. So what we need to take into consideration here is the fact that whatever distance x is, we have to add the radius of the Earth to that, because all our equations work from the center. Okay? So don't get tricked if a question asks from the surface. So it says, what is the force of gravity? Find the weight, which is the force of gravity, at 6.38 times 10 to the power of 6, or in this case, 10 to the power of 3 kilometers, which is the same thing as 1 Earth radius. So therefore, they're saying if the spacecraft is 1 Earth radius above the Earth's surface, what's the force of gravity? Well, if you recognize this, I know this drawing really isn't to scale, but this entire distance would be 2 Earth radius, because here is 1 from here to here, and here's another one from here to here. So the force of gravity is going to equal gmm all over r squared, where r is equal to 2re. Okay? Thing is that I don't know the mass of the spaceship. I know the mass of the Earth. The mass of the Earth is equal to 5.98 times 10 to the power of 24 kilos. But what about the mass of the spaceship? I really haven't been given that, have I? Well, indirectly I have here. Okay? Just a little bit more work. I have to go, all right, well, the mass of the spaceship, let me do that here. The mass of the spaceship is equal to 7.2 times 10 to the power of 3 newtons divided by g, which is 9.8 on the surface. Remember, they said that this weight was on the surface of the Earth here. Okay, so let's just go 7.2 times 10 to the power of 3 divided by 9.8 newtons per kilogram, and we get 7.2 EE3, enter 9.8 divided by, and we're getting a mass of 735 almost kilos. So that's the mass of the spaceship. So now we know that guy. So let's continue on. Let's go g times 5.98 times 10 to the 24 kilos multiplied by 735 kilos divided by, now the radius, remember, was 2 Earth radiuses away because the question said it's 1 Earth radius above the surface, which is 2 Earth radius from the center. So 2 times an Earth radius is 6.38 times 10 to the power of 6 meters, and all that squared. Now what's that going to give us? Here we go. The 735, we can work backwards here, so let's go 735 times 6.67 EE negative 11 times, and then multiply that by the mass of the Earth, 5.98 EE 24 times, and now divide that by 2, enter 6.38 EE 6 times, and then square that, and then divide. And I'm getting force of gravity is 1,800 newtons. So that's the weight. So let's just kind of compare that to the weight on the Earth. So on the Earth, the weight is 7,200, and at that height of 1 Earth radius above the surface, it's a lot less than 7,200. It's 1,800. Okay. Now, the next part of the question says, so that's the answer to the first part. So the weight at 1 Earth radius above surface. Okay. Next part of the question says, what is the force of gravity at a height of 1.28 times 10 to the power of 4 above the surface? So now our new radius is equal to 1.24, or sorry, not 24, 28, my mistake. 28 times 10 to the power of 4 kilometers. Now we have to change this to meters. This is also above surface. So let's change that to meters. So that becomes 1.28 times 10 to the power of, add 3, 7 meters. But remember, we now have to add 1 Earth radius to this in order to be from center. Therefore, we can get the new force of gravity, or the new weight, as being G times mass of the Earth times, again, the mass of the spaceship, divided by 1.28 10 to the 7 plus 6.38 10 to the 6, and all that squared. And what do we get? Here we go. 6.67 EE negative 11, enter. Mass of the Earth 5.98 EE 24 times, 735 times, and then 1.28 EE 7, enter, and 6.38 EE6 plus squared divided by. Answer 797. 797 newtons. So that's even higher, and so therefore it weighs even less. Weight at 1.28 times 10 to the power of 4 kilometers above the surface. And that's the end of this problem. Thanks for watching.